Hi students, welcome to Inview Point. I hope you all have come to know about Inview Point. For those who have not heard about us, let me briefly explain. Inview Point is an online education platform. We offer online tuitions for classes 9, 10, 11 and 12. We also offer online coaching classes for BTech EEE, all semester-wise subjects, whole as a package, or individual subjects. For more information, log on to our website inviewpoint.in, or you can contact us via email at info@inviewpoint.in. So today I thought of taking a demo class so that you get to know more about our teaching technique. In this video, I'll be discussing about motion, an important topic of class 9 science subject. Unless you're clear with the basics of this chapter, you may find it difficult in following remaining chapters of class 9 science subject. So students, let's begin the class. Okay. Motion in everyday life. We see around us a lot of objects. Some may be at rest, like a table or chair in your room, okay, or a board in your classroom. So some may be in motion. Say, for example, birds flying in the sky, or we can see vehicles running on the road, right? So, what is motion? Motion is a phenomenon in which an object changes its position over time. So, what is motion? Motion is a phenomenon in which an object changes its position over time. So students, you may have learned about different types of motions in your earlier classes. I think in class 8 you are studying it. Let's revise it, okay? So there are several types of motions. Some of them are rectilinear motion, circular motion, rotational motion, and periodic motion. An athlete running a 100-meter race in a straight track, okay, that is an example for rectilinear motion. Earth revolving around sun or moon revolving around earth, those are all examples for circular motion. Okay, earth rotating on its own axis, that is an example for rotational motion. Pendulum, we have seen a pendulum, right? Pendulum is an example for periodic motion. Okay, so today in this class we will be discussing about motion along a straight line. Okay, so before discussing about motion along a straight line, you have to know what is a scalar and what is a vector quantity. Hmm? Basically, physical quantities are classified into two, scalar and vector quantity. Okay, scalar quantities are those physical quantities which can be represented by magnitude or numerical value alone. Okay, so scalars are physical quantities which can be represented by magnitude or numerical value, whereas vectors are those physical quantities which are represented by both a magnitude as well as a direction. For example, in the figure you can see two men, Ram and Sham, they are standing 30 meters apart, right? So 30 meter is the distance, right? This is a measurement. You are representing distance by a magnitude 30 meter, right? So that is, distance is a scalar quantity, okay, because it is represented through a magnitude alone. If along with this 30 meter, if you are saying Sham is standing 30 meters east of Ram, okay, then what are you saying? Yes, along with the distance, along with 30 meter, the magnitude, you are specifying a direction also, right? So that is a vector quantity. Okay. So other examples for scalars and vectors are scalar. You can say time. Okay, if you are saying 10 seconds or 6 o'clock in the morning, that is represented only by a numerical value. So time is an example for scalar value. Vectors example is force. Okay, so suppose you are applying 5 Newton force. Okay, 5 is the magnitude of the force applied, and you always apply a force in a particular direction, right? So a force is represented both by a magnitude as well as direction. So Force is an example for vector. So I hope it is clear that scalars are physical quantities that are represented by magnitude or numerical value alone, while vectors are those physical quantities which are represented by both a magnitude as well as direction. So let's now discuss about motion along a straight line. Okay. See in the figure, you can see a house and a school bus. Suppose a student goes to his school by school bus. Okay. So he has to start from his home and has to travel to reach his school bus, right? Suppose he moves along the straight line of 4 meter. Then we can say that the student has traveled 4 meter distance. Okay. Suppose there is a nearby tree or garden near his house. Okay, instead of directly going along the straight line, he can start from his home and go to this tree, and after reaching the tree he can go back to the school bus, right? So what is the total distance, total length of the path covered by the student? It is 2 plus 3 meters, that is 5 meters, right? So here the distance is what? How much? 2 plus 3, 5 meters. So what is distance, students? Distance is the total length of path covered by this covered by an object from the initial position to the final position. Okay, so what is distance? Distance is the total length of path covered by an object from the initial position to the final position. Okay. We always describe the location of an object by a reference point or origin. Okay. So in this figure, what is the reference point or origin? It is the house of the student. Okay. And what is the final position? It is the school bus. Okay. I hope you understood, students. What is distance? Distance is the total length of path covered by an object from initial position to final position. Okay. So what is displacement? See, I told you that the student can go to the tree. He can start from his home, go to the tree, and then come back to, and then enter the school bus, right? Instead of going along this path, he can start from his home, okay, and travel along a straight line to the school bus. Okay, this straight line will be the shortest distance between his home and the school bus. And what is the how much distance it is apart? It is 4 meters apart, right? So what is displacement? Displacement is the shortest distance between the initial and final position. So what is displacement? Displacement is the shortest distance traveled by the object between the initial and final position. And what is distance? Distance is the actual length, total length of path covered by the object. Okay. So the displacement here is how much? 4 meter, right? The displacement is the shortest distance between the house and the school bus. What will be the shortest distance? It is the straight line between the house and the school bus. Okay. You always mention the displacement along with a direction. See, the arrow shows the direction. So we can say that distance. Okay. Distance is a scalar quantity while displacement is a vector quantity. Why? If suppose the student travels from his home along the straight line to the school bus, what is the distance covered? Distance covered is 4 meters itself. That is the actual length of path covered by the student. If you say that he is moving along the straight line, okay, which is the shortest distance, and along with that you mention the direction of the motion, then you can say it is the displacement. So displacement is a vector quantity while distance is a scalar quantity. Is that clear, students? Let us discuss some other cases. Okay, some other examples so that you will be more clear about distance and displacement. See, suppose an object is standing at point O, okay, and an object travels from point O to point B, okay, and it returns back from point B to point O, okay. Then what is the total distance covered by the object? It will be OB plus BO. OB is how much? 10 plus 20, 30 meters. So what is the total distance covered by the object? It is OB plus BO, that is 30 plus 30 equal to 60 meters. See here, you can see that in this case, the initial point is point O and the final position is also point O, right? So what is the shortest distance between the initial and final position? That is 0, right? So what is that? That is displacement. So displacement, which is the shortest distance between the initial position and the final position, is 0. So in this case, we can see that distance is 60 meter. At the same time, displacement is 0 meter. Did the object actually travel? In total, yeah, he did travel, the object did travel 60 meter, but the displacement is 0. What is displacement? It is the shortest distance between the initial and final position, okay. Suppose the object starts from point O, okay, and it travels to point B, and from point B it travels back to point A, okay. So here, what is the total distance traveled by the object? The total distance will be OB plus BA, which is how much? 30 plus 20 equal to 50 meters. Okay, so here the initial position is point O and the final position is point A. So what is the shortest distance or displacement of the object? It is 10 meters. Okay, is that clear, students? Displacement is the shortest distance between the initial and final position, whereas distance is the actual length, total length of path covered by the object. What is the distance? Distance is OB plus BA, that is how much? 30 plus 20, 50 meters, whereas displacement will be OA is equal to 10 meters. Is it clear, students? Okay. Let us consider another example. Suppose an object stands at the point O, okay, and it travels from point O to point B. Point B is the final position here, okay. So what is the distance traveled by the object? That is OB, right? What is the displacement? It is also OB. Why? OB is the shortest distance between the points OB, right? Between its initial and final position. So here distance is equal to displacement. Is that clear, students? So from these three cases, see, we can say that displacement can be either 0, less than, or equal to distance. Okay, see, in the first case, the distance was 60 meter and displacement was 0 meter. So you can say that displacement can be either 0, it can be 0, right? Okay, in the second case, you can see that the distance was 50 meter and the displacement was 10 meters. So here the displacement is less than distance, okay. In the third case, if you see, you can find that distance is equal to displacement. So we can say displacement can be either 0, less than, or equal to distance. Is that clear, students? Okay, students. So now let's discuss what is uniform motion and non-uniform motion. Okay, an object is said to be in uniform motion when it travels equal distance in equal intervals of time. So what is uniform motion? An object is said to be in uniform motion when it travels equal distances in equal intervals of time. Let us discuss about it through an example. See, in this figure, you can see a car, right? Suppose it starts from point O and travels to point A, which is 4 meters apart, right? In 2 seconds. Okay. And again it travels from point A to point B, which is also 4 meters apart in the same interval, right? Same time interval, that is 2 seconds. Then from point B to point C, which is also 4 meters apart, it takes 2 seconds to travel, right? So here you can see that the car takes equal intervals of time to cover equal distance. That is, it takes 2 seconds to cover 4 meters each. Okay, so we can say that the car is in uniform motion. Okay, so what is uniform motion? An object is said to be in uniform motion when it covers equal distance in equal time intervals. So what is non-uniform motion? Now, an object is said to be in non-uniform motion when it covers equal distance in unequal time intervals. See here, the points O, A, B, C all are 4 meters apart. Okay, but the car takes 2 seconds to travel from point O to point A, and it takes 6 seconds to travel from point A to point B, and 10 seconds to travel from point B to point C. See, the car covers 4 meters in each 4 meter in different time intervals, right? So we can say that the car is in non-uniform motion. So what is non-uniform motion? An object is said to be in non-uniform motion when it travels equal distance in unequal time intervals. And what is uniform motion? An object is said to be in uniform motion when the object travels in it covers equal distance in equal time intervals. Okay, so see here, you can see that the car travels from point A to point B 4 meters in 2 seconds, right? So we can describe the rate of the motion of the car as how distance covered in unit time, and that is called speed. So what is speed? Speed is a distance traveled by the object in unit time. Speed is equal to, the equation is speed is equal to distance by time. It is denoted by the letters V. Its unit is SI unit is meter per second. What is SI unit of distance? It is meter, right? And what is the SI unit of time? It is second. So the SI unit of speed is meter per second. Speed can be also represented in other units, centimeter per second or kilometer per hour. Is that clear, students? So let us find the speed, okay, of the car from point O to point A. See, what will be the speed? Speed is equal to, what is the equation for the equation of speed? It is speed is equal to distance by time. So what is the distance traveled here? 4 meters, right? And the time taken is 2 seconds, right? It is 2 seconds. So the speed will be 4 by 2, that is 2 meter per second. Okay. So calculate the speed of the car from point A, B, point A to A to B. What is the distance covered here? That is also again 4 meters itself. 8 minus 4 is how much? 4 meter. And the time taken is 6 seconds. So the speed will be how much? 4 by 6. Distance by time, that is 0.66 meter per second. Okay, is that clear, students? Then calculate the speed of the car between points B and C. The speed will be how much distance by time. That is, what is the distance traveled here? It is 4 meters and the time taken is 10 seconds. So the speed will be how much? 4 by 10, that is equal to 0.4 meter per second. See here, the car travels in non-uniform motion. Why? We can say that it covers equal distance in different time intervals, right? In unequal time intervals. So see, students, we can see that the car takes different speed to cover the same distance, right? So we can say that the car is in non-uniform motion. Okay. So when an object is in uniform motion, then we can say its speed is also uniform. And when an object is in non-uniform motion, then its speed is also non-uniform. Okay. So when an object is in non-uniform motion, its speed is also non-uniform. Okay, so most of the objects will be in non-uniform motion itself. Okay, so in order to find the speed of the total journey, okay, we express the speed in average speed. Okay, so how we find the average speed? Average speed is equal to total distance covered by total time taken. Okay, that is v is equal to s by t. So what is average speed? Average speed is equal to total distance covered divided by total time taken. Okay, so let us find the average speed of the car to travel from point O to point C. Okay, what is the equation for average speed? It is total distance traveled by total time taken. So what is the total distance traveled here? It is 12 meters, right? OC is 12 meters apart. And what is the total time taken? It is 2 plus 6 plus 10. Okay, so that is how much? 18 seconds, right? So what is average speed? Just directly substitute the values in the equation. So you get average speed is equal to total distance traveled by total time taken, that is equal to 12 by 18, that is equal to 0.66 meter per second. Is that clear, students? Okay. So let us do a numerical problem. See, the question is, an object travels 16 meter in 4 seconds and then another 16 meter in 2 seconds. What is the average speed of the object? Okay, suppose the object is at point A and it travels to point B, which is 16 meters apart, and from point B it travels to point C, which is again 16 meters apart. We are assuming the points to be A, B, and C. Okay, the data is given in the question. See, an object travels 16 meter in 4 seconds and then another 16 meter in 2 seconds. See the in the question. So what can we infer? We can say that the object travels equal distance in unequal time intervals, right? So what it is? That object is in non-uniform motion. Okay, is that clear, students? The object travels equal distance in unequal time intervals. So we can say that the object is in non-uniform motion. Here in the question, they have asked what is the average speed of the object. So what is the equation for average speed? Average speed is equal to total distance covered by total time taken, right? So what is the total distance traveled here? That is 16 plus 16. That is how much? 32 meters. And the total time taken is what? 4 plus 2. That is 6 seconds. So directly substitute the value in the equation. You'll get average speed is equal to 32 by 6, that is equal to 5.33 meter per second. Is that clear, students? Okay. Then, I hope you are clear with what is speed and what is average speed. Speed is the distance traveled by an object in unit time. The equation for average speed is equal to total distance covered by total time taken. Okay. So, what is velocity? Let's study what is velocity. Okay. So, what is speed? Speed is a distance traveled in unit time, right? So if you along with the speed, if you mention the direction of the speed, then you get velocity. So what is velocity? Velocity is the speed of an object moving in a definite direction. So what is velocity? Velocity is the speed of an object moving in a definite direction. This velocity can also be uniform or non-uniform. Okay, how can you change the velocity? You can either change the speed, the magnitude, right? Speed is represented by magnitude. Okay, so you can either change the value of speed or you can change the direction of the speed. Okay, or in order to change the velocity, you can change both the speed as well as the direction. Then also the velocity changes. Is that clear, students? So velocity can be changed by changing the value of speed or changing the direction or changing both the speed and direction. See, so speed is always represented by a numerical value, magnitude. Suppose it is, here you can see the car. Let the car be traveling in 50 meter per second. So that is the speed of the car, right? When we say the car is traveling in 50 meters per second, you are describing the speed, okay, and that speed is given by a magnitude value. Along with this, if you're saying that the car is moving in 50 meters forward or towards east, then along with the speed you are mentioning a direction, then it is velocity. So we can say that speed is a scalar quantity while velocity is a vector quantity. Is that clear, students? So speed is a scalar quantity while velocity is a vector quantity. Okay, so now let's find average velocity. In the similar way, we found average speed. Okay, the equation for average velocity is equal to total displacement by total time taken. Please note here, students, average speed is equal to total distance covered by total time taken. In order to find average velocity, instead of distance, what we do, we have to divide the displacement, total displacement by total time taken. Is it clear, students? So average speed is total distance covered by total time taken, and average velocity is total displacement by total time taken. For uniform motion, the equation to find average velocity is average velocity equal to initial velocity plus final velocity by 2. Okay. Suppose initial velocity is u and final velocity is v. We represent the equation as VAV is equal to average velocity is equal to u plus v by 2. Is that clear, students? So let's solve a problem to find an average speed and average velocity. Okay. So the question is, Usha swims in a 90-meter long pool. She covers 180 meter in 1 minute by swimming from one end to the other and back along the same straight path. Find the average speed and average velocity of Usha. Okay, so here in the question it is given the length of the pool is how much? 90 meter, right? So I assumed it to be of rectangular shape, the swimming pool to be of rectangular shape. That doesn't matter here. You just you have to know the distance traveled, okay? Distance traveled and displacement, because you have to find the average speed and average velocity, right? So here the the length of the pool is given as 90 meter. Is that clear, students? So the second statement says that Usha covers 180 meter in 1 minute, right? How? By swimming from one end to the other and back along the same straight path. Suppose Usha starts from point A, and then in the question it is given she swims to point B, okay, and from point B she swims back to point A. Okay, is that clear, students? So the total distance covered by Usha is how much? 180 meters. It is given in the question. Okay, and the total time taken is how much? Total time taken is 1 minute. Okay, so you know the SI unit of speed is what? Meter per second, right? So here the time is given in minute. So you have to convert this minute into second. So 1 minute is how many seconds? 1 minute is equal to 60 seconds. So you know the total distance here and the total time taken. So what is the average speed? Just directly substitute the value in the equation. So you get average speed is equal to total distance by total time taken, that is equal to 180 by 60, that is 3 meter per second. Is that clear, students? So you got the average speed of Usha, right? So how did you get the average speed? I'll repeat it once more. Average speed is equal to total distance covered by total time taken, right? Here in the question it is given that Usha covers 180 meter, that is the total distance, in 1 minute. Okay, 1 minute is the total time taken. You know the SI unit of speed is meter per second. So convert this minute into second. So you'll get the total time taken as 60 seconds. So average speed is equal to how much? Total distance by total time taken. That is 180 by 60 is equal to 3 meter per second. Is that clear, students? So now let's find what is average velocity of Usha. Okay, what is the equation for average velocity? Average velocity is equal to total displacement by total time taken, right? So we have to find the total displacement. What is displacement? Displacement is the shortest distance between the initial and final position of the object, right? So here it is said that suppose Usha starts from point A, she swims to point B, then after reaching point B, she swims back to point A. So here the initial and final position is what? Same. Point A itself. So what is it? Total displacement here? It is 0, right? So the initial and final position is same. So here the shortest distance between those points are what? Is what? 0 itself. So the total displacement is 0 meter. And the total time taken is how much? 1 minute. It is given in the question, right? So you have to convert this 1 minute into seconds. 1 minute equal to 60 seconds. Then directly substitute the values in the equation. Average velocity is equal to 0 by 60, total displacement by total time taken. So you will get the average velocity to be 0 meter per second. So you got the average speed as how much? 3 meter per second, while the average velocity was how much? Is how much? 0 meter per second. I hope students you understood what is velocity, what is speed, what is distance, displacement and all. Uh, I took a long motion in one class itself. So it may be a bit difficult for you to understand all these portions together. So this is just a demo class. The actual classes will be more elaborative and explanatory. And through frequent live interactive sessions and mock tests, you'll be able to clear all your doubts and perform well in the examination. So thank you, students. That's all for today's class. Please like, share, and subscribe our channel and log on to our website inviewpoint.it to join our courses. Feel free to contact us through mail at info@inviewpoint.in. Wish you all a good day. Thank you. See you in the next class. Bye.